Hello students, in this video we'll be studying about Message Digest version 5, that is MD5. In previous video we have studied about what is Message Digest and how we can use to achieve the integrity goal of security by using Message Digest. Now today we are going to see the very well known Message Digest algorithm, which is MD5. So this MD5 is until recently the most widely used hash algorithm, and it is specified as Internet Standard RFC 1321. This message digest algorithm MD5 it was developed by Ronald Rivers at MIT. So as we have seen RSA algorithm, so the inventors of RSA has also invented this MD5 algorithm. The logic of this MD5 algorithm is it takes the input message of an arbitrary length and it produces an output of 128-bit message digest. The input is processed in 512 bits block, 512 bits block, and processing consists of multiple steps. So let us understand all these steps in detail. Before applying MD5 algorithm to any arbitrary length message, first we have to pre-process the message. So this is the original message of k bit long. Any arbitrary length message can be used. After that, we have to append the padding bits so that we can make this original message multiple of 512 bits. Because just like your block cipher, where we have some specific size of block and we have to make the message multiple. So here we are making the message multiple of 512 bit by adding some padding bits to it, and the last 64 bit are reserved for appending the message length. So whatever is the length of message that we have to represent in 64 bit, and then we have to append it at the end. So the total message after padding and appending the message length must be multiple of 512 bits. Now once we make it 512 bit long, every block of 512 bit is processed. And it is given as input to this MD5 block or MD5 algorithm. Now currently this is a black box for you. So just remember here this MD5 is taking two inputs, 512 bit block from the original message and 128 bit of initialization vector. And after that it is producing the 128 bit of output. Then that 128 bit of output of first MD5 block is used as initialization vector for the second block, and then second 512 bit block of original message is processed. Likewise, the output of last 512 bit block is 128 bit message digest. So this would be considered as a final message digest of this original message of k bit. Now this initialization vector which is of 128 bit, it can be represented as 4 words, and these are the 4 words. This is a constant. This initialization vector is constant. So this is how your MD5 algorithm works. So the very first step here is to make the message multiple of 512 bit, and for that we are adding the padding bit and 64 bit of message length, as I told you. See, remember here the last block of MD5 message must be 448 bit long, because then we have to add the 64 bit of message length to it. So the entire message will become 512 bit block. So the last block of your MD5 is of only 448 bit from original message, and the remaining last 64 bits are for storing the message length. So first we have to pair the message so that its length will become multiple of 512 bit block, and last block is 448 bit. We have to append a 64 bit original length value to the message. Then we have to initialize the 4 words, that is 128 bit of initialization vector, which we are calling those 4 words as message digest buffers or MD buffer. Then we are processing the message in 16 words, that is 512 bits each block at a time. and then that message is processed by using 4 rounds of 16-bit operation on the message block and the buffers. Then we have to add output to buffer input to form a new buffer value. That is, it means that those buffer value or these 4 words of MD buffer are updated in each round, and the output hash value is the final buffer value. So let us understand it step by step. So first is step 1 is the padding twist, that given the original message M, we have to add the padding bits. Now while adding the padding bits, the first bit would be 1 and the remaining bits would be 0. Okay, so that to make the block multiple of 5 and 2 bit. So while adding the padding, first bit must be 1 and the remaining bit should be 0. Then we have to append the original length in bits mod 2 raised to 64. So it is representing the message length into 64 bit. And then the third step is the final message is chopped into 5 and 2 bit of blocks. Then step 2 is we have to append the length, as I told you that the 64 bit represents representation of the length of B bit. So the length of message before padding bits is to be added. Then in some unlikely events that B is greater than 2 raised to 64. So in that case, only the lower order 64 bits of B is to be used. Then third step is we have to initialize the MD buffer. Then in this step 4 word buffer, that is A, B, C, D. They are used to compute the message digest. So here each word is of 32 bit and total they are making 5 and 2 bit of block. 128 bit. So these registers or these buffers are then initialized to these following hexadecimal values, and these are the fixed values. So word A will be initialized to 01, 23, 45 and 67. All these are the hexadecimal values. So all 4 are making 128 bits. The next step is we have to process the message into 16 word block in 4 rounds. So first we have, as I told you, there are 2 inputs to your MD5 block, 5 and 2 bit block from original message and 128 bit of initialization vector. So this 128 bit of initialization vector is divided into 4 words A, B, C, D, each of 32 bit, and they are initialized to some fixed value. Inside this, it is processed in 4 rounds. Every round consists of 16 steps. So this is your first round, which consists of 16 steps. We will number them from 1 to 16. So this is the function which is taking 3 values here, and then processing these 4 MD buffers and this 5 and 2 bit of message block. Then how this is processed, that we will see in the next slide. Then the output of the 16 step would be given as input in the form of updated MD buffers. See, these ABCD values are updated here in the first round, that is in 16 steps. Then that would be the input to the next round of 16 steps. So updated values of ABCD MD buffers are acting as the initialization vector for round 2 and next 16 steps. Then we have the next 16 step with from 33 to 48 with the updated values of these MD buffer, and then final 16 steps. So total 64 steps are used in 4 rounds. And finally then the output is XORed with the original 128 bit of initialization vector, and then we are getting 128 bit of message digest. Now the function which we have seen in the previous slide is called as MD5 compression function. It is responsible for updating these 4 MD buffers A, B, C, D. So how it is processing? When we are giving these 4 words of 32 bit each as an input to the function, it applies the function G on the 3 words B, C, D. Then the output of this function G is XORed with the first word A. Then what we are doing is we are adding it with xk, that is a round constant, and then with ti. So the significance of xk and ti we will see in the next slide. And then we are applying some shifting operation on that, and then these buffers are updated. The function which is used in the comparison function of MD5, which is the heart of this algorithm, is F, G, H and I in the four rounds. As we have seen that 16 steps are there in one round, total 64 steps. So in every round, the different function is used. So in the first round, when function f is used, it is using three words, and this Boolean operation is performed on these three words. So that is xy or not x into z. So such kind of Boolean functions are used. Then this xk is it's a shift constant which is used by MD5, and there are 16 different shift constants used in every round, and these are the constant values. So this is how your MD5 algorithm is working, and it is generating 128 bit of message digest.